Good afternoon. This is Giri Venkatila from Bureau of Research. Thank you for joining us today for this Lunchtime Tech Talk webinar. Today's Tech Talk is one of a series sponsored by NJDOT Bureau of Research that include webinars, Lunchtime Tech Talks, and other events. Tech Talks are meant to share and promote the implementation of research and innovative practices and the transfer of knowledge among NJDOT staff and others within New Jersey's transportation industry. In this Lunchtime Tech Talk webinar, we will learn more about recent and ongoing research funded by NJDOT through the Pavement Support Program. The Pavement Support Program, or PSP, has several objectives and touches upon many disciplines, from material evaluation to supporting payment management activities to address payment design needs, to assisting in training and workforce development. In short, the PSP is an extension of the NJDOT workforce activities under the direction of the Payment and Drainage Management and Technology Unit at NJDOT, which also helps to support the needs of the NJDOT Materials Bureau. Today's Tech Talk features a presentation from Dr. Thomas Bennett of the Center for Advanced Infrastructure at Rutgers University. Now I would like to introduce our moderator today, Omid Sharmad. Omid is a member of the Technologies Transfer team. Omid will moderate the Q&A portion of today's webinar and introduce Dr. Bennett. Thanks again, and I hope you enjoy the presentation.
Thanks so much, Giri, and welcome everybody to today's Tech Talk. Before we get started with Dr. Bennett, we just want to take care of a little housekeeping first. Dr. Bennett will speak for about 50 minutes about his research for the PSP program, and we'll have 15 minutes for Q&A immediately afterwards. Feel free to submit a question anytime throughout the presentation. To submit a question, please use the chat box in the bottom right-hand corner. We'll be gathering questions throughout the Tech Talk, and then Dr. Bennett will field them at the end. Professional development credits are available if you stay for the full session. Your name must be included among those who registered today. And please, at the end of the event, you should receive a quick survey pop-up. Please complete that. The feedback helps us improve each presentation, as well as giving you an opportunity to provide input on what you would like to see presented at future Tech Talks. We'll be looking to wrap up around 1:15. So without further ado, today's Tech Talk features a presentation from Dr. Thomas Bennett of the Center for Advanced Infrastructure at Rutgers University. Dr. Bennett has served as the Principal Investigator of Pavement Support Program since its inception in 2016, and will continue to serve as the PI following the recent award of the PSP contract through 2025. Dr. Bennett's Tech Talk will provide an overview of the Pavement Program's recent deliverables, as well as highlight the future goals of the program. Dr. Bennett is an Associate Research Professor at the Center for Advanced Infrastructure and Transportation. Dr. Bennett is a leader in performance-based specifications for asphalt mixtures, in the characterization of asphalt mixtures and binders, forensic analysis of asphalt pavements, pavement design, evaluation, and rehabilitation of transportation infrastructure, and the beneficial use of recycled materials. Dr. Bennett is also the supervisor of the AASHTO-accredited Rutgers Asphalt Pavement Laboratory, which is accredited for over 60 different AASHTO and ASTM test procedures for asphalt. Dr. Bennett serves on the TRB AKM 10 Standing Committee on the Production and Use of Asphalt and AKM 40 Standing Committee on the Asphalt Mixture Evaluation and Performance. He has published over 60 peer-reviewed journal papers, conference papers, and has received 3 KB Woods Awards for the best paper in the field of design and construction by the Transportation Research Board. When not working, Dr. Bennett can be found on the soccer pitch and the ice hockey rink with his family. So without further ado, Dr. Bennett, I'll be sending it over to you.
Thank you, Omid. I appreciate it. I'm hoping that you can hear me okay.
Yeah, we hear you.
Okay, great. So thank you very much for the honor of discussing the research. As you, going back, I realized, wow, that was a very long intro. So I apologize for that overly lengthy bio. Regardless, but what I'm going to talk about is the Pavement Support Program, something that we've been working on for what is quite a long time, honestly, and you'll see that. And as it was said in the intro, what this program really is, it really is an extension of New Jersey DOT. That was the original intent. And so that is really how we've always viewed this, that the work that is here is an extension, and the work also goes to implementation. Nothing gets just put on the shelf and forgotten about it. Everything gets moved right into the implementation mode. Before I start, I have a series of acknowledgments because, again, we have been doing this for a while now. On the New Jersey DOT side, we started back around 2006 on this, actually, this concept back with Andy Umicus, who's retired. After Andy left, Robert Sauber took over for a little while. He's now retired. And now it's run by Susan Grasavage. But Robert Blight, Narinder Kohli, Nusrat Murshid, and Sharad Rana are now over in that division and are doing an excellent job at keeping this program moving and doing what payment management design and technology unit is supposed to do. On top of that, as was mentioned, we also work with the materials group. Eileen Sheehy, who was a longtime manager there, is now retired. Paul Anzarek retired. You know, in doing this, I realized I've been around for a while because I keep seeing retired. I seem to be the last dinosaur left here. Ed Inman, who's now the manager of the Bureau of Materials, and along with Stephen Gontier, who's working down there as well. Ashok Patel, who also retired. So there's a large group of New Jersey DOT that has been heavily involved from the start and involved on all these activities. Along with that, I can't forget our Rutgers and Kate grouping, the Rutgers Asphalt Pavement Lab that does a significant amount of work on these projects. Ed Wass, Ed Haas, Chris Erickson, Drew Tulanowski, and Nick Sitowitz on asphalt materials, data analysis, forensic studies, a tremendous group over there that we have. A fantastic administrative staff at Kate. And then our key support staff, which you are seeing here. Nick Vitillo, who was working at New Jersey DOT and then came over to our center to do some work with us. He's since retired. But Brian Tobin, Hal Wang, John Hankin, and Michael Boxer all have significant roles in this program. And I'll discuss those individually as we move forward. Again, the Payment Support Program is funded through the State Planning and Research Program, the SPNR. And it's under the guidance of Helene Roberts from Federal Highway. One of the things that I have to say that's really great about this program is everybody involved seems to really take ownership in it. And Helene does a fantastic job at really being involved, going to trainings that we have, not just our scheduled meetings, but it's involved in additional meetings just to see how things are going, progressing. She's fully invested in it and seems to really believe in the program and the process. So it's great to always have a champion like that behind you as you move through these projects. Again, the main goal of this whole program is to support the activities of the Pavement and Drainage Management Technology Unit. That's under the current management of Susan Grasavage right now. So everything that's done in here is to support those activities. Part of those activities do also relate to what the Bureau of Materials needs to do as well. And there is that direct link between materials and pavement performance. And that has to be known that you can't have one without the other. If you try to understand one, you really have to know the other. So they're directly linked. That's why you'll see that a lot of the work that we do is also materials heavy, because we are always trying to figure out that link between pavement performance and also the material characterization. Prior to 2016, the PSP program was actually a yearly contract. In fact, it was originally developed in 2006 with Andy Umicus. Again, the concept being a support arm, a support program for that division. In 2016, it eventually just went to a 3-year program. One of the things that, as you'll see in some of the examples that I provide, continuity is important in a lot of this work, because sometimes it's not just 1 year to complete some of these tasks. And then as you're constantly building, moving forward, that continuity is very important to continue that forward progress. So in 2016, it was a 3-year contract, and then 2 years were added. The recent award was 2020. That is a 5-year award with the option for a 5-year renewal. So again, trying to maintain that continuity to keep moving forward as we progress. And I'll show you in a minute how important that is. As we mentioned again a couple of times, this is an extension of the DOT's services. We're not trying to push any agenda except what DOT wants and needs. That's really the idea. We meet formally each quarter to discuss progress, but I'll tell you, I spend a lot of time with the staff throughout the week, whether that's now with Zoom calls or Microsoft Teams, or going out into the field and looking at pavements, looking at construction processes. So there's a lot of time spent between there. 2 of our people, John Henkin and Michael Boxer, are actually at New Jersey DOT 2 to 3 days per week in the offices, working with the staff and working with that group intimately. So there's a lot of work being done very closely there, just to, again, to make sure that everything that we're doing meets their needs. When we talk about deliverables, a lot of these deliverables come in forms of technical memorandums that are completed upon a subtask. And what you'll see is we've got these 7 major support tasks here, but within each one of these tasks, we have a subtask. So we may have 3 different mini projects going on in innovative materials within 1 year. And as these things get completed, we're immediately providing information to the group so we can make very quick decisions. New Jersey DOT, again, looking for immediate implementation here. And that's really the major goal, is not to study something for 2 to 3 years, come up with a conclusion, and then see if we want to use it or not. Everything here is really being researched and looked at for immediate implementation. Or the opposite, we realize that it's not ready for implementation and it's not being used. So these 7 major tasks that you'll see here: innovative materials, innovative technologies, payment management system and development. That's number 3. Number 4 is payment design procedures. In task 5, we look at some life cycle cost benefit analysis. Task 6 is payment policy decisions, and task 7 is technology transfer and training. It almost sounds like something from the Jeopardy categories, but those are the 7 major tasks that we work with New Jersey DOT in supporting their initiatives. And this little schematic that I have here, the idea of this is to kind of give you an idea of our general philosophy of how we handle this work. We don't really think of it ever as being fully completed, because we're always going back and reevaluating to see if things can be done better once they've been implemented. Can we modify a specification? Can we change a material? Can we look at different construction practices? So, we first come up and sit down with New Jersey DOT and look at a task or idea identification, or maybe something needs to be modified. There's obviously a focus, research, and evaluation process that goes along with it. And this usually results in some sort of an analysis or specification development that we look to quickly put into an application or a pilot project. We then go ahead, take a look at how these things are performing, usually within the payment management system, field visits, visual distress surveys, and look to see where modifications to the procedures and specifications may need to occur. And then again, we go back into this cycle again. And again, this is a never-ending process. We're always looking to improve. We're always looking to make things a little bit better. We're always trying to see how specifications can progress, because as we all well know, the industry is quickly changing. Material processing is changing. Construction practices are changing. Analysis programs, computing power is changing. So all of these allow us to continue to progress. This is the general effort tree, as you would say, from the program. Up top here, you have Helene Federal Highway, Sue, who's Grasavage, who is the manager and essentially the program manager for the PSP, and then her staff over Pavement Technologies and Design, her major staff, and then Materials Bureau. The group that we generally have when we go ahead and have all our quarterly meetings and general meetings. Myself, the PI from Rutgers, and then we have, again, as I showed you before, Michael Boxer, John Henkin, Hao Wang, Brian Tobin, myself. We all are managing different areas of these tasks. You'll see that there is a lot of overlap too. There's a number of people that are on task 2, people on task 3, 4, and that's because we're always working within different subtasks within those different groups. So there's a lot of overlap between what we try to do. We want there to be good rapport and back and forth. It's sort of a way that we data check and quality check each other to make sure that things are progressing and moving forward. And to date, things seem to be going well. You see this trend on my kids with TikTok or Instagram or Twitter, how it started, how it's going. So here we are in 2006. This is the New Jersey DOT network system. You can see here that in 2006, this is where the PSP basically started. New Jersey DOT rated 49% of their payments as deficient. They had 39% that they deemed fair and 12% that they deemed good. And this is all based on payment management information and data. And then you move forward to see how we're doing now. And what you'll see is a nice increase or a nice improvement over this time period. Again, looking at where we were at 12% good up to now as 40% good. And constantly moving that up. You can see here in these last 4 years in particular, were the last 4 years where we've actually had more percent of the payment network that was in good condition than in poor/deficient condition. A lot of that has to do with some of the work that we're doing, some of the philosophies that we're helping with New Jersey DOT implement and moving forward. And I will tell you that I can see this constantly going upward with how things are going. Very proud of this particular schematic because I guess when you look at it from a research perspective and does research work, do these programs that New Jersey DOT utilize and work, I think this really says a whole lot to that this shows a lot of evidence that what we're doing here is making a big impact in the state. So from the aspect of working with this program for this number of years, this is one of the biggest takeaways that I am very proud of and clearly shows the impact and the value of these sort of programs. Okay, so get into some examples of what we're talking about here. So we're going to bridge a large gap going from materials to training. I'm going to try to give you sort of like a quick flavor, almost like a beer flight per se, giving you an idea of a little bit of a taste of everything, just to give you an idea of what we've done, what we're working on, and also an idea of what we're moving towards in the future and what to see in the next coming years. So what's innovative materials? What exactly are we talking about here? Well, the idea behind innovative materials is we're looking to develop new specifications for quote unquote new construction materials. And I put that in quotes because sometimes new may actually mean recycled. It may mean that we're taking something that's old, but finding a new use for it. So we're looking for new construction materials, new materials that are going to improve the life. Sometimes we target specific pavement areas, such as composite pavements, which we'll talk about in a little bit. Sometimes we target certain technologies like pavement preservation, where we're targeting better materials to preserve our pavements. And sometimes we're targeting areas that are directly related to safety and how we can improve the safety of our roads. So we're looking at not only just developing new, but how can we improve existing? And that's really what the innovative material task circles around. Just some examples of some of the stuff that we've done. Since about 2006, what we've been doing in New Jersey is we've been pushing the use of what we call performance-based design. And what that really means is that historically asphalt and concrete are designed based on volumetrics. how much asphalt can I get within a gradation to ensure that I also have a certain amount of air. And this is important based on historical information. If we meet certain volumetric criteria, the material should perform well. But we know that with the advent of a lot of new additives, materials, production practices, that these volumetrics don't necessarily hold. So what we've done since 2006 is actually developed a series of performance-based materials targeting at certain areas that are critical. For example, over here on the left, we have what we call a HPTO, which is a high performance thin overlay. That's a pavement preservation type of material, goes down 1 inch or less, but adds a significant improvement in structure and flexibility, durability over the pavement while sealing it. So a very good mix, again, requires the use of performance testing to make sure that it's both rut resistant and crack resistant. We have a bridge deck waterproof surface course mix. The intent is, again, to preserve our bridges. The benefit of this actual material is that you don't need an underlying membrane, waterproof membrane. This acts as that on its own. And also because it's placed at about 1 inch thick, you can reduce typically the dead load weight of bridges by about 50% if you're going to use an asphalt overlay. Most asphalt overlays are 1.5 inches to 2 inches. This goes down to 1 inch, goes down at 1 inch. So you're significantly reducing the dead load weight of the material just by using something like this. And this has been found to be extremely rut resistant, extremely durable, crack resistant, and impermeable, and used on structures like the George Washington Bridge and a few other steel orthotropic bridges in the immediate area. So a very good material. We also have what we call a bottom-rich intermediate course. This is for the bottom of our asphalt overlays over concrete. And then we also have developed a bituminous-rich base course. And this is used when we're trying to produce what we call perpetual pavements, where we're designing and constructing a pavement so it does not crack from the bottom up. The only distresses that occur are on the surface, which can be milled off and then replaced. So in essence, we have a long-time, long-lasting structure in place. And what we've done with a lot of these mixes during the development is also taken a look at it, since again, we've said we've had them since 2006. We've looked at how they've performed over time, and we go back into the pavement management system data, get an idea of how they look, and come up with a general, what we call a deterioration curve, which I'll show you, and get an idea of how much longer they last over conventional asphalt. And that's sort of the idea here. So again, here's our high performance thin overlay. This was the first project ever placed. This was 295 down in South Jersey. And the material, I believe, lasted 10 years before it was actually pinned between a north and southern construction project. So they decided to take it all up in one shot, but performed exceptionally well. And again, what we've done here is we've looked at what drives performance, looking at the factors to watch, such as the materials, things that we can recommend to inspectors while they're out on the job. But then also looking within the pavement management system, we can see that this material lasts and actually increases the pavement life over 5 years greater than our typical hot mix asphalt overlays, our typical what we would call a mill to pave to process. So those 5 additional years, now you can go ahead and allocate money to someplace else. So we're finding that, again, in this sort of practice, as long as we're putting them on sound pavements, obviously you put it on garbage, you're going to get garbage, but we put them on sound pavements, they're going to perform rather well. We've done similar work with our other materials, such as bituminous-rich intermediate course, SMA. And again, for those of you that may not be aware, New Jersey, although it looks like we traditionally have mostly asphalt pavements in the state, over 60% of the network that's owned and operated by New Jersey DOT is what we call composite. And what that is, it's concrete, an old concrete pavement with asphalt on the surface. That presents a very significant challenge for designing because of the movement around the joints and the cracks. So what we've done through research is verified and validated is what we call a system approach, where we use a 3-inch overlay over top of these composite type pavements, where we use this 1 inch of the bituminous rich intermediate course on the bottom and 2 inches of an SMA over top of that. And what we have found is that by using this approach, we can improve the life of the composite pavements by over 8 years. In some cases, looking at some of the data in some of the pavement sections, we've had to extrapolate that data out even further because the performance has been so good, we haven't seen deterioration. In this bottom schematic here, you can see these blue and yellow lines. The yellow line is, or the blue line is your typical HMA, only really lasting about 2 to 3 years before we generally see cracking. We start to see some issues on these composite pavements. When we're talking about this bituminous rich systems, this SMA in the brick, we're out in this range over here, where we can go ahead and now we're predicting a good almost 10 plus years of life extension. So this has been something that has sort of, I don't want to say changed the game for composite pavements, but it has significantly improved the rideability and the serviceability of composite pavements in New Jersey. And the same thing with what we call SMA, stone mastic asphalt. It's something that industry can be a little bit opposed of at the time. There is a little bit of a higher cost per ton. We're not using or allowing recycled asphalt pavement there. And you have to really pay attention to the details. Because if you don't, the construction process can be a little bit challenging. But what we found, again, going back into the pavement management system, is that when we're putting these on flexible pavements, now non-composite, putting them on traditional asphalt pavements, you can see the improvement in life over your typical dense graded mix, whether it's a 9.5 or 12.5 millimeter SMA. We're talking 5, 6, 7 years easy of a life extension over these pavements. What New Jersey DOT typically is doing after a certain amount of service life on these is actually going back out and preserving them with some sort of a preservation treatment. They're lasting that long and performing that well. So again, going back and verifying, so these technologies or these materials were developed, the specification was out there, going back, continually monitoring them, seeing if we have to change anything, but then always looking at the performance to make sure that we're moving forward. Again, we talked heavily about recycled materials. Now, this was a particular project where New Jersey DOT had allowed the use of what they call recycled asphalt shingles, as long as they were what we call post-manufacture. Now, for those of you that have never heard this before, recycled asphalt shingles, or asphalt shingles in general, have about 10 to 20% of asphalt by total weight. They also have some fibers in there. They also have some coarse sand in there, some granular sand in there. But they have about 10 to 20%. So there's a possibility of including these in an asphalt mix because of the compatibility, or somewhat of a compatibility, between the binders. There are some significant differences, though, when we talk about the asphalt, because the asphalt in these shingles are much stiffer, and they're modified in a way so obviously when it's very hot out, that asphalt doesn't drip down the side of your house. So the stiffness of these materials is much different than what we would conventionally use. And at the time, there was a little bit of pressure on the New Jersey Materials Bureau to take a look at this again. It was in the specifications, but people hadn't used it in quite a while. And so we went back, took a look, did a research study looking at this proposed AASHTO method that they were proposing. And again, the idea here is, can we actually responsibly use recycled asphalt shingles in new hot mix asphalt? And we looked at a surface mix, we looked at a base course mix, could we put it deeper in the structure? We looked at the rutting, we looked at the cracking, and what we found was that the stiffer binder improved the rutting resistance, but it promoted cracking. And it promoted cracking to the extent where it really wasn't even close to our conventional type mixes. Now, that doesn't mean that these products still can't be used, but you're going to have to significantly modify the way that we currently treat our asphalt mixes by using what we call rejuvenators, using some sort of a chemical package to soften the asphalt binder in the shingles. Again, looking at a softer asphalt binder. And mind you, this is really only for the manufactured waste. So this is only for the waste product that comes from the factories. Currently, the New Jersey DOT does not allow post-consumer or tear-offs, old shingles from housing because of the possible asbestos that might be in there. Again, we're going through this study. We were looking at both products. The post-consumer had testing done on it to see whether or not there was asbestos in it, but both products are still too stiff to be used just as is without significantly doing a redesign of some kind. So in this case here, this was an instance where we were looking at a recycled product, but it just didn't work. At least it didn't work under the current system without some significant modifications. We look at here's a product for safety called a high friction surface treatment. And this is something that is becoming popular for horizontal curves in trying to reduce fatality accidents of people actually, unfortunately, leaving the travel lane. And some really interesting statistics that there's approximately 5% horizontal curves in all U.S. roads. About 5% of all the roads make up these horizontal curves. But when you look at the rate of fatalities, it makes up 23% of all fatalities nationally. That's a significant amount of fatalities for a small portion of the pavement network around the country. In fact, in New Jersey alone in 2016, they mentioned that there was 336 fatalities due to these lane departures on these particular areas. So these systems of trying to maintain friction in these horizontal curves has become of a serious topic recently. And one of the ways of trying to help this is a product called a high friction surface treatment. This was developed during the Everyday Counts initiatives by Federal Highway. I think it was Everyday Counts 3, if I'm not mistaken, 3 or 2. And really just to simplify it as best as I possibly can, what we're doing is we're taking a very hard angular stone, which is this calcined bauxite, and we are gluing it to the pavement. And you can see on the picture on the left here, this is an epoxy resin that is applied evenly across the pavement surface. Right now, what you're seeing is a picture from underneath the system where this calcined bauxite is now being dropped down onto the epoxy. And that's allowed to sit and set up for a little while until the epoxy hardens. And then the material is brushed, the loose material is brushed and swept off, and your final product looks like the picture on the right. It can be a little bit of an expensive treatment. The aggregate is very expensive because it's a bauxite stone, but then it's superheated to create the hardened effect that gives it its hardness. It's very angular on itself, but then they actually go ahead and process it to harden that material up. There are some other specifications that go along with it. It has to maintain a certain skid resistance. But when you go about going through the general design process, its recommendation is to be placed on a pavement in good condition. The problem there is, what is the definition of good? We can actually pave a brand new road tomorrow, but we can actually make that asphalt to a condition where it feels very old. So the problem that we get into is, what is good? And when we don't know what is good, we get into some of the distresses that you see below. This is what we call a shallow delamination. What happens here is that epoxy surface that's on the top with that resin, that essentially shears and rips off that top ½ inch of the asphalt pavement. And in doing so, you're left with these, what looks like almost like a very shallow type of a pothole. And what is really happening here is that as we get into these temperature cycles, especially these larger temperature cycles within a 24-hour period, the expansion and contraction of the epoxy is far greater than what is occurring in the asphalt. And if the asphalt is at the wrong condition, this expansion and contraction can basically rip the material apart. And that's what you see here. You see these shallow delaminations. Even in the picture on the right, you can see where the HFST started and basically started, and where the existing HMA stopped. and you can see basically what looks like a transverse crack right at that edge, and that's because that HFST section is expanding and contracting right at that edge. You can also see a little bit of excessive epoxy that was left on that road. That obviously is a problem as well because there's really no friction to that. So we actually looked at a number of different pavement sections that had HFST on there, looked at both good and poor performing, and what we were able to do in this study were two things. The first one was to actually design a pre-screening protocol that can be used to determine whether or not pavement sections, asphalt pavement sections, are good candidates for HFST, for epoxy resin HFST. And you can see down here, we look at a property from the asphalt binder. So we have to recover some of the asphalt binder from the surface of the pavement. And then we also look at what we call the pull-off strength. And that's shown in the pictures above where we're running a pull-off strength to determine how strong the HFST bond is onto the pavement. So we can run these series of tests to pre-screen the asphalt pavement prior to application to make sure that these distresses don't occur. The second thing that we also did is we also developed a high friction chip seal product, something that we're evaluating. There's a section of it on, oh my gosh, Route 68 right now. And we're looking at a couple more applications around the state where, as opposed to an epoxy resin, we're using a heavily polymer modified asphalt binder to actually do the gluing, something that's more compatible to the asphalt pavement. So we're looking at these other alternatives, again, looking at existing specs, how can we continue to improve them? And in this case here, you can see that although the intention of this specification was good, the conditions in New Jersey may not lend itself to being applied universally across all pavements without some sort of pre-screening being done. Things that we're going to be looking at moving forward, something that's very hot in the industry right now, recycled plastic. We've got some work going on right now and potentially a pilot. So we're moving forward on that. Electric arc furnace slag, another recycled material. This material can be produced into an aggregate form. Slag has generally been known to be harder and a little bit more angular, a little bit more abrasion resistant. So can we use some of this material in asphalt applications? Implementing new design procedures, something called balanced mixture design, which is something on the asphalt side, again, incorporating performance tests. And then also looking at central plant cold recycling, where we bring these essentially a portable asphalt plant to a location. We mill the material, the wrap up from that job, reprocess it, and essentially put it all back. It's basically a 100% recycling system. They've been used on smaller projects down in, I'm sorry, not even smaller, but they've been used in a number of projects down in Virginia. We had a nice presentation from the folks down at Virginia Transportation Research Consortium on this. And so it's something that we're looking at trying to pilot soon in New Jersey. We talk about innovative technologies. And again, this is task 2 of the PSP. And in innovative technologies, what we're doing is we're looking at practices and equipment that can be implemented to improve the evaluation of construction materials, as well as improving construction practice in general. So really seeing how we can improve the way things are made or how we evaluate our materials. First thing I want to talk about on the construction side, we see longitudinal joints. And a longitudinal joint, if you don't really know, is we pave in a longitudinal manner during the length of the pavement, but we can't shut off an entire road. So what ends up happening is we end up having to pave one side and then pave the next side within a couple of days later. And that edge where we pave up against that cold new edge is what we call a construction joint, or in this case, a longitudinal joint. Unfortunately, construction practices in general, we end up seeing that along these edges here, we have an area of low density, what we call high air voids in the asphalt industry. And that allows water to get in. You can see here the picture on the right, which I love, by the way. This is actually ice that's formed on the surface from water that is essentially freezing and expanding up and out of a longitudinal joint. So this was water that was actually trapped in the joint that during a freezing cycle in the winter has actually pulled up and out of the longitudinal joint area. Now, the problem with this is that during these sort of cycles, you really start to weaken that joint up. And then you start to actually see that fall apart during these freeze-thaw cycles. That on top of any sort of moisture damage. And what you end up having is you end up almost having to rehabilitate a pavement, not due to premature failure of the material, but due to the construction practice itself. So we're looking at ways of improving longitudinal joints with performance specifications, a specification that we developed for New Jersey, which is really based on the permeability that we expect out of those areas, and also looking at ways to seal those joints up. We're running a couple of pilot projects now on a material and a process, if you look on the bottom right here, called a void reducing asphalt membrane, or VRAM for short. And this helps to actually seal up that joint area, not just along the face of the joint, but as you put the hot material above it, it actually wicks up and starts to clog that joint area to reduce that water to go in. So we're looking at a number of these technologies to help improve that. Unfortunately, at the current moment, there's not an existing way to necessarily improve the construction of the joint. So what we're trying to do is figure out a way to best seal that joint up without creating a significant change in the whole construction process. Pavement bonding, and this is something that is extremely important, and it's due to the way that we construct asphalt pavements, or all pavements in general, and that they're constructed in layers and vertically move up. So if I'm going to go ahead and take off the top 2 inches because it's distressed, I would mill 2 inches off, and then I would place 2 new inches on there. But we have to try to glue that new lift onto the bottom, and that's very important, because if we don't, then what ends up happening is we get into a situation where we can have slippage, which is these nice pictures on the bottom. This is some recent pictures that we took at on a field, little quick field visit with the pavement management group. And you can actually have where you have these breaking areas and the top layer just slides. Or you can also have a situation where we have the upper schematic here, a tension mode where we just don't have any bonding. And what ends up happening is that that entire surface lift has to take up all of the stress. And in doing so, you get a significant amount of bending, a significant amount of deflection, and that will cause the material to crack much sooner. So the idea is to make sure that we get bonding of these layers to reduce this slippage, to reduce this potential for premature failure in that surface area. And here's an example of basically what happens. And I love this schematic. Somebody was just smart enough to put this together. The figure on the left is a 60-pound weight, and it's on, I believe, about 5 sheets of plywood. Now that plywood's not nailed or bound together, okay? Basically, they're just sitting on top of one another. And you can see here that they measured a 1/2 inch of deflection with that 60-pound load. They then took the same sheets of plywood, they nailed them and glued them together, allowed it to basically cure and harden. And then after that, they put weight on there, and they had to increase it up to 160 pounds just to get a 1/4 inch of deflection. Now, it's the same wood, same thickness. The only difference there is that in one situation, they were completely unbonded, and in the other situation, they were fully bonded. And this is a great analogy for asphalt pavements and what happens. That if we don't get that bonding, we get a significantly greater amount of deflection that these materials really should not or cannot withstand in most cases. And in doing so, we get premature failure. So there's a couple of ways that we're looking at researching this now. One is to find out a way to better characterize the materials that we use to bind these layers together, which are called tack coats. Historically, they've been used in what is called a penetration test, where we push a needle into a sample. The deeper that needle goes in 5 seconds means it's soft. The less it goes into the material means it's hard. And there's certain requirements that are needed for what we call tack coats. But by no means does whether this material being hard or not dictates how it's going to perform in the field, how it's going to bond. So we're actually looking at better procedures. We're looking at what we call bond energy, which is exactly more of a pull-off type of a test that can be used in existing equipment. There's actually an ASTM procedure that's being moved forward on it. And this methodology has been shown to be able to differentiate between different material types as well at different temperatures. And really what we see here is you see the DSR, the dynamic shear rheometer that we use for binder characterization, just pulling upward and pulling the material. In this case, this was a polymer modified emulsion, and you can see the material that looks like it's stringing or stretching. It almost looks like chewing gum in the summer. And this test method has the ability to better characterize our tack coat materials. So that's one important thing. So we can go ahead now and specify better materials that are going to bond better. But in the end, a lot of it also comes down to construction practices, how well we actually construct our pavements. And there's a number of areas here that in these pictures where there's improvement to be made or errors that are involved. In the first picture here, you can see it's a milling practice. Now, what has to happen after this milling practice, again, we're taking off 1.5 to 2 inches of old material. You can see old dust and debris fines that are on this road. This has to be removed. So we have to come in with a sweeper. Usually there's some water involved, and all this has to be removed or the bonding is just not going to be there. On the right side here, you got a construction practice. Here's our tack coat. And you can see here, it's not necessarily evenly distributed. In fact, we get what we call ribboning, which is just these streaks here, these longitudinal streaks where we just get a little bit of material coming out of the back of the distributor truck. And in that case there, we're not going to get enough material down to provide a good bond. Essentially, we've got not enough glue. And in this case, over on the bottom left, you can see areas that are bare, and this has been picked up by construction trucks. Basically, what ends up happening is they get stuck on their tires and they start tracking it down the road. Obviously not very good. And then also on the bottom one, you see this little brown, watery looking material that's out here. What that is that's tack that hasn't broke yet. So this tack coat material is mixed with water in a chemical package so the oil and water do not separate. And what that allows you to do is it allows you to get it down more evenly at lower temperatures so you don't have to excessively heat it, but you're going to get full distribution. But you have to allow that material to cure and what we call break, meaning the water evaporates. And in this case here, they started paving way too early. And what happened was that they actually paved over material, over a tack coat that was still water and had not broken yet. So all of these things will impact the performance of how well we get bonding. So what we're trying to do is help develop a end result spec. We're looking at a core bond strength test. We're doing some round robin testing now on 5 different projects at 2 different times after construction to see if aging is significant. And there's 3 laboratories participating to get an idea of what the repeatability is and what sort of criteria we're looking for on this sort of material, this sort of practice. But a critical part in the construction process of our asphalt pavements is ensuring we get that bond. Other work that we've done, and I don't know how many people have heard about intelligent compaction, and really what we're doing is we're putting a bunch of sensors on the back of a paver and our rollers over here to get an idea of what the temperature is. So here's an IR gun. We're looking at an infrared image of the temperature of the pavement as we're placing it and compacting it. And then we also have GPS sensors on these equipment so we can get an idea of the number of passes, where that roller has been. If we can get even coverage, good even density, then we should be able to get better and longer lasting pavements. The schematic on the right is from a project that we did. We evaluated a couple of years ago under the PSP. And you can see on the right here, we've got different color coding. Red being 1 pass, that means the roller's gone over at once. Orange is 2, yellow is 3, green is 4, light blue is 5, darker blue is 6. And you can see that for one road, there's really not a necessarily even number of passes. In fact, we go from anywhere down here to 1 pass over that road, all the way up to 6 passes, depending on where we are. The more passes, the more times you have, the more chances you have to better compact the material, and less likely that you're going to get poor in-place material. Because the higher the lower the density of the material, the higher the airvoids and the more likelihood you're going to get accelerated aging. So we look at these things and combine the number of passes with the infrared to get an idea of the number of passes versus density. And we can look at the how well these pavements are being constructed. And the equipment operators can look to see where they've gone and where they have to go to try to get this. And we can explain anomalies like this, where at 5 passes, we have airvoids between 4.5 to almost 2.5% airvoids, but that was simply because of the difference in temperatures that we're seeing on the pavement. So we can look at combining these technologies to help improve our construction. We also look at noise, how noise is generating from the pavement surface and tire. Obviously something very important. We've got a lot of residential areas that are built up along our highways. So we're looking at measuring pavement noise and seeing how it changes over time. And we've been doing this for a number of years now and have a large database. We're looking to see how different materials behave over time, and are some pavements getting louder than others over that same time period. Other materials or other technologies we're looking at and coming up soon, looking at different ways of characterizing the asphalt binder and mixes, trying to get, again, a better idea of how these materials are performing, including performance testing during production, incorporating sensors on New Jersey DOT fleet vehicles, trying to see if we can use some of the fleet vehicles to actually help us get an idea of how our roads are performing, and looking at texture measurements to help predict friction and skid properties. Skid resistance is something that's measured, but can be very costly to actually run the test and to maintain the test. So can we do this at a traffic speed using texture? This way we don't have to disrupt traffic at all. Task 3 is pavement management. And again, a lot of the work that we do here is to assist New Jersey DOT on the collection of their data, the quality control and analysis of the data, and then using that data to help make decisions. And again, the idea with most of pavement management is, should I leave it alone? Should I invest a little bit of money in pavement preservation? Am I going to go ahead and have to do some rehabilitation, which is going to be a little bit more costly? Or am I going to have to go in and do some major reconstruction? And then within those areas, we have to decide what type of materials are we going to use. So it's collecting the data, it's analyzing it, making sure that it's quality, and then using that data to help make decisions, not just now, but then also predict how that pavement is performing in the future so we can allocate further on out. Things such as condition forecasting, where depending on the budgets that's provided, how can we properly utilize the money to make the payment system look and perform better? And again, so we go through a lot of these budgeting scenarios, looking at whether or not we should use pavement preservation, how much pavement preservation, whether we should look at larger rehabilitation projects. So we do a lot of these simulations and work depending on the data that's coming in and the cost of these programs. The PMS condition and program mapping, looking at different sections and trying to map them based on construction. Where's construction going? What kind of pavement preservation practices do we have out there? Looking at projects that are now undergoing for rehab and construction. We're currently looking now at mapping out noise, seeing where there's hot spots and noise along pavement. So we're looking at mapping programs and mapping capabilities of the data, taking the data in, putting together so we can get a better visual idea of how things are performing out in the field. Looking at automated distress. This is something that's been very popular in the past couple of years. In the past, New Jersey DOT has actually rated the pavements visually, having people behind the wheel. Obviously, the person behind the wheel isn't doing the rating, but other people are in the car or in the van and actually rating the pavement as they drive over it at traffic speed. But now we have systems where we can use downward and forward viewing cameras to actually pick up these cracking distresses. And we can take those distresses and then index them in a more accurate way than what we were doing prior, just through our eye. We can actually get low severity cracking in some of these systems. something that we weren't able to do before. So moving over completely to more of an automated distress type of a mode. We've also, in the past couple of years, have developed and are currently working on maintaining calibration sites for New Jersey DOT equipment. On the upper right here, you can see their pathway vans. This is the network data collection system that they use with the downward cameras, the rut bar, looking at smoothness. And on the bottom right here, you can, and that's over at their Seagirt facility. This was New Jersey. And then the bottom right here, this is a out-of-service rest stop on 287. And here we're using the walk-behind SurePro profiler that we use for bridge deck acceptance. So we do a lot of this. We're able to find these locations with New Jersey DOT, go out there, index these locations, and then utilize them for equipment verification. So New Jersey DOT equipment goes out there on a schedule to go and make sure that they're calibrated properly, and even to the point where at times we bring in consultants that have similar equipment that New Jersey DOT contract with to help support their activities to make sure that their equipment is calibrated and matches New Jersey DOT. Upcoming capability or upcoming activities here. I apologize. I'm starting to talk a little bit faster as I see I'm hitting close to that 1 o'clock mark. We're looking at combining databases of getting materials and payment management designed to talk so we can see the interaction between materials and performance. We're always looking to continue to enhance the equipment calibration sites that I just showed you. That's a constant effort, constantly moving on that. Incorporating GIS models, improving and processing our QC/QA processes, trying to speed those up so we can get data into our payment management system sooner to make better decisions. And then looking at developing material-specific models. Right now, and in most state agencies, we currently just determine asphalt and concrete as separate materials, but we want to now even separate them even more. What type of asphalt, what type of surface? So we're looking at material-specific modeling now. Task 4 is payment design. And again, the idea here is we're in a whole new world with regards to payment design. Up until, honestly, and there's some states that are still doing it, they're using the system from the 1960s ASHO road test. And it was ASHO, I didn't forget the T, they didn't have the T in it back then, but this was a series of roads that they produced in Illinois and had known traffic driving over it that they measured and measured the distress of the different sections. And then they developed these nomographs where you were able to go ahead and determine how much thickness you needed based on equivalent damage of the different pavement sections. So you knew what your traffic was, what kind of reliability you were looking for, what sort of supporting stiffness material you had, and then you came up with a thickness, or really what you needed was a structural number, and you related that to thickness. Again, archaic in the way that it was done. It was all based on statistics, based on traffic and information back in the 60s. What it doesn't do is it doesn't allow us to really look at how the material is performing. And now with the advent of computer speed technology, we know how to better characterize our pavement materials. We can go ahead and do a much better job at predicting performance. And I will tell you, payments are the most difficult structure, and I do consider it a structure, to actually model, just because of what is going on. You don't have a material that always has a constant constant value, a constant structural value. If you look at the graph over on the right, you can see here the asphalt material is constantly changing almost hourly, also depending on the depth. So the stiffness of that material changes based on temperature, loading speed, and depth away from the load. The granular materials are all seasonally changing, and they're all changing based on load. Concrete changes. It actually increases in stiffness over time. The one thing, and then you've got traffic, and that's also increasing as well. So you have all of these things that are constantly changing. It's like trying to hit a moving target. But now we're with the computing speed and better understanding these materials, we're able to better model these materials right now. And that's in a new system, a new design methodology called Pavement ME, ME standing for Mechanistic Empirical. And what we've been able to do under this program, under the PSP, is start to go with the loading. get the traffic information from the state DOT, simplify it, because currently, or the older design wanted the equivalent single axle load, your easels, but now what the new pavement ME wants is the information that made up the easel. What was the axle spacing? What was the tire pressure? What was the axle load? What was the vehicle class type? So we've been able to consolidate this down into what we call traffic families, which represent different areas of New Jersey to make it simpler for New Jersey DOT designers to actually utilize the loading conditions. We also go ahead and are developing material catalogs. So we can go ahead and design pavements ahead of time. You know, the problem is we do a design and then it gets constructed years later. Well, we don't necessarily know what the materials are going to be. This catalog now allows us to get a better idea of what representative material properties are going to be. And so we take existing materials, we break them down, we take the asphalt off it, we look at the gradations, we look at the material properties, how it performs, and provide data information that can be directly uploaded into the program that, again, designers can use that better represent the materials that are going to be out there. We go into model calibration of this system, taking information that we have in the payment management system, putting the information into the models, and then looking to see just how good they are. You can see here, this is a predicted and observed cracking, fatigue cracking by percent of the wheel path before, and then you can see here after our initial calibration after. You can see a much better, a much greater improvement after the initial calibration process. So we're looking at doing these things, how different materials handle. Should we actually have to, and we are actually, coming up with different calibrations for different asphalt material mixes. We're looking at different calibrations now for our typical polymer modified, our neat asphalt materials, and then now also our stone mastic asphalt SMA, because it's being used on so many different pavement surfaces around the state. And we've got a lot going forward on this as well. We're including specialty mixtures in our modeling calibrations. We're looking at improving our rehabilitation design methods to actually measure material properties from field cores, taking the very specific layer information, and calibrating some of the newer modules or newer models in the pavement program itself, such as the reflective cracking model, which is important for us considering we have such a large amount of composite pavements in New Jersey. Again, I apologize, I'm trying to move faster. I only have another 70 slides left, Omid, so I should be okay. Task 5, life cycle cost analysis and cost benefit ratio is an area that we look at. And again, the idea here is what's cost effective. If we go ahead and we select a material and it proves that it gets us another 5 to 10 years of pavement life, well, that's great. But if it costs 1,000 times the amount of something that we would typically use, it may not necessarily be cost effective. So how can we go about looking at this? Can we look at cost benefit analysis programs, trying to figure out what sort of life extension we can get, and then look at the costs associated with that. And we've been able to do that with pavement preservation techniques, looking at different pavement preservation, whether it's a microsurface, crack seal, a mill to, pave to, and come up with analyses of what are better treatments and at what particular time should those treatments be used. If we use them too late, well, we're not going to get as much life out of them as maybe if we use them sooner. That's why the general public at times gets confused. We go out, we pave a road, 3 or 4 years later, we're doing a pavement preservation treatment on there. It's not that the road's in bad shape. We're putting a preservation treatment on there because the road is in good shape and we want to keep it in good shape for a lot longer. So those sort of techniques of pavement preservation, even though it looks like we're doing them more frequently, allows us not to get to this threshold where we have to start worrying about a rehabilitation. And we also do that for materials. You know, there was a lot of initial talk about these specialty mixes, needing to make sure we do performance testing. Is it worth it? Well, we went back and did a nice cost benefit analysis of it and showed that all the materials that we're using have an increased benefit ratio over typical asphalt because of the extension of the life is much greater than the difference in the additional cost of some of these materials. And we've been doing that for a lot of our specialty mixes that require this performance type testing that industry may not necessarily always prefer to use. In task 6, we look at things that affect payment policy. what are some areas that we could possibly be doing that may actually change our practices completely, okay? Whether that's payment preservation, whether that's potentially the onset of autonomous vehicles. And these are usually done in a white paper sort of a format where we do surveys, we go do literature reviews, literature searches, and come back to New Jersey DOT and say, look, this is what we found about this particular topic, whether or not it should be used or how other states are currently using it. Things like traffic speed deflectometer. So this is a method where we actually take a large truck, just as you see in that schematic, which is highly instrumented to actually determine the deflection under the axle. And so this gives us a little bit more of a realistic structural approach to what we currently have out there. And we had a couple of demos of this equipment. The one manufacturer came out, we had them run a couple of days worth of pavement sections. And the idea is that it's supposed to give you information very similar to going out there and looking at the structure with what would be what we would currently do on a project level analysis. So what this would do here is change the way that New Jersey DOT currently is actually looking at doing things, which is doing a network analysis, identifying areas or pavements that need to be possibly rehabilitated, then doing a project level analysis where a more detailed structural analysis is done, and then providing recommendations. This has the ability to possibly do both. And we looked at a number of sections, and you can see here these squiggly purple lines. There's the deflection that's measured from the vehicle. And then also these red spots are deflections that were measured from the conventional project level fall and weight deflectometer. And they fall on each other quite well, showing that for these flexible pavements that we looked at, that this seems to be a promising technology. And we looked at ways of determining what's remaining structurally in the pavements. Can we back calculate a modulus for the asphalt? Can we back calculate a modulus for the subgrade materials, for the unbound materials? And we can. And because of the GIS system, it allows us for some very nice mapping possibilities as well. The problem that came out of this really, though, is it's not a system that's ready yet for composite pavements, because of just the small level of deflections that we typically see from this device. And with over 60% of composite pavements in New Jersey, it may not lend itself to full application. We are working with the company. It looks like that they're going to come out possibly again to run some more composite pavements. They've sort of looked at their system and made some modifications. They've got better technology now that allows for better measurements. So we're going to go back and take a look at this. Again, like I mentioned earlier, we look at something, we kind of do that full circle, come back to it. And as the technology improves, we may see that this might be something that could be potentially used across most pavements in New Jersey. Again, maintaining the profiler site. You know, we developed it, we do training with it. This is something that, again, is sort of a game changer in New Jersey and actually needed, according to the FHWA TAMP regulations, that we have to verify all measurements. And so what we're doing in these systems is making sure that our systems, that New Jersey DOT's equipment, is properly calibrated, making sure that we can verify these measurements, and not just one equipment, but the equipment across the board, whether it's New Jersey DOT owned or whether it's consultants that are also doing the work on there. Some things that we're looking down the road, whether or not we can use longitudinal tining or grinding practices for friction in horizontal curves, something that might be able to be used instead of the high friction surface treatment. The impact of autonomous vehicles on pavement performance. As we start to hear about the development of autonomous vehicles, how are they going to be utilized on the pavements? Is this going to impact our design, impact materials that need to be used? Looking at potentially of how can warranties be used on projects to make sure that if a project does go bad, New Jersey DOT isn't paying for it, that the pavements that are being constructed and put in place have a certain life, minimal life, that is warranted based on the contractor. And then also looking again, like we mentioned earlier, about the fleet to help aid in pavement monitoring. Last but not least, our training activities. Again, the idea of everything that we're trying to do is implementation. So not only are we taking these different subtasks and products and presentations, technical memorandums, and all these reports and getting them to New Jersey DOT as soon as possible, but we're also providing training for their group. we're talking about different materials and construction technologies, going into the Materials Bureau and helping them with performance testing, going and looking at pavement designs and doing training on the new the pavement ME systems, PMS software, SurePro, walking profiler training. We do a lot of training just regarding the high-speed profiler use and guidance, making sure that that's how is it supposed to be calibrated. So there's a large training component that we do with this group as well to make sure that they're up to date with the newer technologies and just the general practices, because that continuity is important. Because as there's turnover in New Jersey DOT, we have a significant amount of continuity at our research center working on this for so long that it does provide that level of security when it comes to certain turnover, people retiring at New Jersey DOT, that there's still a place to go where we can still provide that level of training for everybody. Wow, that was over an hour. In summary, again, the idea behind this support program, it was an initiative to support the immediate needs. And I really want to emphasize that it's the immediate needs. We really do work to try to get that information to the group as soon as possible, and in a means that they can go ahead and make a very quick decision on something. It's all about really the implementation here. And, between us, New Jersey DOT, and the industry, what we found is this is a significant amount of success that sort of falls right in that middle there, where we've been able to really, I believe, improve the system, improve the materials that we're currently using in New Jersey. New Jersey is one of the leaders around the country in performance testing for asphalt pavements, how they handle composite pavements. And I would like to say that a lot of that is due to what this pavement support program has been able to accomplish in that time period. Oof. That's it. I appreciate your time. If I didn't put you to sleep and you have any questions, I'd be happy to try to answer them. I apologize. We're coming right up over on that 1:15. But again, if there's any questions, I'd be happy to try to answer them as best as I possibly can. So thank you very much.
Thank you, Tom. That was a great presentation. I know it was going long, but we didn't want to stop you because, I mean, everybody's still here and it was just jam-packed with information. And there are quite a few questions, so let's get to them right away. Sure. First and foremost, how does New Jersey compare to other states in our use of high-performance thin overlay? Are we using it more, less, or about the same as other states?
So right now, myself and Robert Blight, who is within the Pavement Management Technology Group, are actually working with Federal Highway Everyday Counts, the EDC 6 initiative, with the high-performance thin overlay. In fact, what we're trying to do is work with Federal Highway to get that type of material out among the state agencies across the country, because it seems to be a very high priority on a lot of the states that were surveyed. Where we are compared to a lot of states is we use it as significantly much more than I would say any state out there, maybe besides Texas. Texas has a version out there which they call a thin asphalt mix or a thin overlay mix, something like that. Same concept, same material. You have to do performance testing, and that's really the key to it. It's not just a typical asphalt material. You have to do performance testing during design and production. But New Jersey is one of the leaders in the country regarding that. And not just that, but in performance testing in general. During the shutdown, Federal Highway did a lot of interviews regarding performance testing, and New Jersey was one of the 7 lead states selected in that survey. So whether or not the group on here from New Jersey DOT know it or not, you are a leader in the country regarding that area. So it's something to be proud of. There are a lot of other states that are trying to mirror their programs off of what New Jersey DOT has done.
That's great. And on a similar vein, how widespread is the use of the high friction surface treatment in New Jersey? Have there been recorded successes? Like, do we see locations where it's been used where there's been crash reduction?
Yeah, so, well, and again, I don't have the crash reduction data, so that's something that I don't have, but I do know it's been used successfully, not just by the state, but the local municipalities have seemed to grab onto it pretty quickly as well. There have been some instances where we've had some failures, which is what I showed in those pictures. And that was the idea of doing that work, try to figure out what was the reason for the failures and what could we do to possibly stop that in the future, or at least reduce the potential for it. But it has been used successfully by the state as well as also municipalities. But again, the idea, there are some instances, where it just isn't working because of just the material it was put on. And that was the whole reason why we have the high friction chip seal as well, which is an alternate surface treatment that we're looking at to possibly be a substitute.
Now, there was also a follow-up saying that they read in the HFSC guidelines that you had observed some early loss of skid resistance despite the very hard aggregate that was used. And why do you think that drop happened?
Simply just due to it loosening in the epoxy. One of the things that happens is embedment depth of that aggregate is very important. So you don't want it to be embedded too deep where the epoxy, where the aggregate is almost drowning in the epoxy. And you don't want it too shallow where it can actually pull out very easy during traffic. So what they say in those specifications about monitoring those first couple of years for friction is to look for those things, to make sure that your embedment depth wasn't too deep where you're not getting the friction that you were hoping for, or vice versa, that the embedment depth wasn't enough and now these aggregates are actually starting to pull out in traffic. So that's what they were looking for. I will tell you that HFSD also has a certain shelf life. And when that shelf life goes, the aggregates start to pop off and that friction drops down very quickly. We've seen that on a couple test tracks actually, where that can happen as well. So monitoring that friction is something that's important because obviously you want to catch that before you get to that stage.
Sure. How many sub-consultants do you have on this project, and which private consultants do you have as sub-consultants?
Wow, that was a lot of consultants. To be honest with you, as of right now, the only group that we have on here is the company that manufactures or developed the pavement management program system. That's the only one that we're actually working with right now. There are some subtasks at times where we're asked to work with people. If there's something going on with a pavement that we have to take a look at, we'll be asked to work with that group. But the only group that currently we have working with us on the contract right now for this year is the company that actually manufactures the software for the pavement management system. Now that might change because again, it depends on the needs of the pavement management and technology group. But that's the only group that's on there to date. Or I shouldn't say they're to date, but that's on there for this contract.
Okay. Sorry to just keep going through these rapid fire, but we have a lot of questions.
Absolutely.
Reach as much of them as possible. Could you speak to the research or potential research regarding pavement mix testing regarding future climate concerns? For example, more days over 95 and needing a more heat tolerant mix.
Yeah. So there are obviously there's two things on that side, and that deals with the high temperature performance of the material. And what ends up going on is that we have ways of characterizing the liquid and characterizing the mix. And so we have tests in place and we have thresholds that we know that the material should be performing at, or we may have issues in the field. And we actually use those thresholds if we're doing forensic work as well, just to check that maybe something happened during the construction process, it might have been contaminated somehow, and that allows us to get an idea of whether or not that material, or why that material failed. The additional heat, though, is also working on the opposite side, where it will also stiffen the material a little bit more. So depending on regional climate, for example, if I put the same asphalt material in New Jersey as I do Texas, that material in Texas is going to age faster because of that heat. That heat does stiffen the asphalt product. So what potentially could happen along those lines is that we could get some increased or accelerated stiffening. Now, we have been working with New Jersey DOT on selecting appropriate asphalt materials and test methods to help, I would say, identify materials that are prone to aging. So we have some protocols in place that we are working on as well. In fact, that was I believe in test 2, where we're looking at better asphalt binder test methods. And those, we have some practices that we're working on now to help identify those areas. So yeah, we do have the tests and criteria in place for the high side, but at the same time, it's also going to affect some of the aging that occurs in these materials. The asphalt will age a little bit sooner. So we do have some protocols in place that can help identify those materials that could happen to sooner than others.
And on the flip side, what is the future of cold mix asphalt and its potential use in heavily truckloaded New Jersey highways?
Wow, man, that's a good materials question. So I think where we stand with it now is, again, we're looking at it from an aspect of more of a base mix. Okay, meaning that again, New Jersey's traffic is high in its parking lots. I mean, that's just the way that the state is. So we don't really have what we would call low volume roads where we can just put some of this material out without some sort of an overlay. Right now, we do have a section that we did cold in place recycling with a thin overlay over top of it. I can't remember the road off the top of my head, but that's performing very well. In fact, I believe it just got a micro surface treatment on top of it, a pavement preservation treatment. But based on the low volume traffic, that seems to be okay. I don't think we're there yet when it comes to anything in the surface, because we are worried that if we don't have enough confinement, sometimes this material can actually break apart a little bit. There are, again, some ways moving forward in technologies of trying to look at enhancing that with potential polymers, but you're dealing with very specialized systems. What I'm really looking forward to is the central plant technology, which will allow us to take material from a project at that project and put it right back. So we're almost looking at basically a 100% recycling of that material back on that project. Again, this would be a base application, so it's going down into pavement. We're providing confinement and holding it down. But I really like that potential technology to help reduce some of the recycled asphalt pavement stockpiles that we have around the state.
Great. And I think we're going to do one final question. And this is, did you test ultra thin friction coarse, and how does it compare to HBTO? Okay,
so ultra thin friction coarse is now the general name for what used to be called Strata. Strata was a proprietary product. That material goes down at about a ½ inch to 3/8 of an inch thick. So it's better compared to, well, it's sort of in between what we would call an open graded friction coarse and a chip seal. So it's a very thin type of material. It's used for more of a pavement preservation. We're not really going to get much structure out of it. But it does do a very good job at sealing off the pavement. And we have found in previous studies, it is a quieter type of a surface application. The high performance thin overlay is different because it's an inch thick, and that's actually improving the structural integrity of the pavement. So not only are we sealing it off, but we're also adding some rutting resistance, and we're also adding cracking resistance. So there's a difference in the thickness of the material and the difference of the targeted application. The ultra thin is really a pavement preservation that is meant really just to seal the pavement off. The HPTO is also a pavement preservation, but that's more of a structure that we can actually get an improvement in the structure of the pavement with.
All right, Tom, thank you so much for the presentation today. There was a lot of really great information there. So we want to remind everybody here that it's going to be posted on the website with a recording. We want to thank everyone for their interest in attending today and for all of the questions. Please be sure at the very end to fill out submit the feedback survey for today's event. It should be available after the webinar is closed. Tom, thank you so much again.
Thank you. Appreciate it. Yep. Thank you, everybody. Have a great weekend. Great rest of the summer.